Imagine yourself waiting for your code to compile and upload just to see if those minor tweaks to your graphical design are showing correctly on your display. That's not quite right. Okay, you just have to change some parameters in your graphics functions and wait again for the compiler and upload process to reveal the results. Now it's getting better. But there should be a more efficient way, right? Now picture yourself changing your design and playing with the parameters of graphic functions while seeing the results in real time on your display. Yes, you're seeing that correctly. I'm using the serial monitor to send graphical commands and interact with my display in real time, eliminating the need for compile and upload waits. I can prototype my designs quickly and effortlessly. I achieve this by using the FastDisplayPrototyping library. It supports any displays compatible with the Adafruit GFX or TFT SPI libraries. I used it to prototype my Star Wars tactical display with lightning speed. In this video, I'll guide you through everything you need to know to start using the Fast Display Prototyping library. I've broken the content down into chapters, and I recommend watching them all, as I'll be sharing valuable tips throughout the video to enhance your prototyping experience, while demonstrating the full range of graphical commands available at your fingertips in the serial monitor. So let's get started and transform your design process with the Fast Display Prototyping library. To install the library, you go to my GitHub repository, and I've put the link in the video description. So you're going to land on this site, which is an open source project, so the library is free of charge and you can even contribute if you want. So you go here on the right side, under the release section, you're going to see at the time of recording, this was version 1.2.4. And as you watch it, it's probably a higher version, but that's not a problem. So you click on the latest version, and you're going to download the latest zip file. So you click on the source code zip file, and it's going to download the zip file into your download folder. So the next thing you have to do is open your Arduino IDE, and to install the library, you go to the sketch menu, include library, add zip library, and you're going to open the library you just downloaded. So it will be Fast Display Prototyping. It's a zip file. You click open, and it's going to be installed. So now the Arduino IDE has installed the library, and it's ready to be used. Once the library is installed, you have two examples provided with the library to get you started at prototyping. So you go into File, Examples, and under Fast Display Prototyping, you have two choices. So if your display is supported by Adafruit GFX, you can choose this example. And if your display is supported by the TFT SPI library, you choose this example, the TFT SPI. In my case, I'm going to start the demonstration of the library with a 2.4-inch TFT LCD display that is supported by Adafruit GFX. And it comes with, in the form of a shield that I installed into an Arduino Uno. So I'm going to select this example. Okay, perfect. This is the Adafruit GFX example. And obviously at the top, we need to include the Adafruit GFX library. And this is the section here that is specific to the type of display that you're going to use with the library. So in my case, I'm using for the demonstration a TFT LCD shield display. So this is the lines of code that I need to add to be able to use the display. So you need to change that based on the type of display that you're going to use. So that's the only part of the example that you need to change. So after that, we initialize the fast prototyping library. And in the setup function, we initialize the serial communication. And since I'm using an Arduino Uno, it is set at 9600. And in the main loop function, this line of code is very important. It is where the library is reading what you will send through the serial monitor to the Arduino and draw the shape on the display according to the command that you send through the serial monitor. This is my setup for the demonstration. So you see my LCD screen on the right, and I'm going to upload the example to the Arduino. So by uploading the example, I'm actually uploading the library that we're going to use. I will open the serial monitor and make sure in the serial monitor that the no line ending here is selected. Now let's try our first command. Let's print a text to the screen. So the command to print the text is TT. So let's print hello world. So hello world is printed. And you see that here on the serial monitor, the actual command to print the hello world text is outputted on the serial monitor. So later on the video, I'm going to show you how to reuse this in your code. So now let's change the size of the font, which is the command TS. Let's change it to a size of 2. I hit enter to send a command. And let's print again the hello world text. So hello world. So now it's much bigger. And you see that the cursor is moving. So let's move the cursor with the command SC to column 0, line 100 with the SC command. I hit enter. And now instead of writing again the TT command to print the hello world, what you can do actually is use the arrow key and scroll through the pass command that you entered. So using the arrow keys in the serial monitor, I can go back to pass command that I entered into the input of the serial monitor and send them again by hitting enter. So this time the hello world is written at line 100 on the screen. So let's change the color of the text by using the command hashtag. And let's print a blue color. So 001F, these are color codes that are in RGB 565 format. And there is a great website that gives you all the color codes for every colors. So I've put the link in the video description. You don't have to remember all those codes. So let's change it to 001F if is blue. So let's send it to the Arduino and reprint again the hello world text. So now it's in blue. So let's clear the screen with the command X. And let's draw a line. This time the command is DL. So from position 00 to position 240 to 320, which is actually the size of the screen. So a line is drawn on the screen, and since we set the color to blue, the line is in the blue color. And as you saw, the format of the command are 2 letters, mostly 2 letters. And after the 2 letters, we have the actual parameters of the graphic function. So you see here, it's draw line and the parameters. And here we have to specify the actual color when we use the function drawLine into the code. But with the library, you don't have to specify it again. It's reusing the color that you set with the hashtag function, this one. Now that's a good way to test colors using the hashtag. So let's say, for example, I want to have my line red. So I use the hashtag to change the color. So red is F800. I scroll again to draw the line, to go to the command to draw a line in the serial monitor using the arrows keys. I resend it, and this time my line is red. So I can do it again. Let's say yellow, which is FFE0. Draw the line again by using the arrow keys. I scroll back to the command, resend it, and this time it's yellow. Now, as we go through all the commands available within the library, I'm showing at the bottom the actual documentation of the command, but you don't have to take any notes on that. Every command is well documented on my GitHub repository. The link is in the video description. So after the video, you can go check out all the documentation and try every functions that you want for your prototyping project. Now, here is the fastest way to have the width and the height of the screen. So when I draw the line using the command DL, so 0, 0, I specify the actual size of my screen. So instead of doing that, the library, there is a shortcut. So instead of specifying the actual width in numbers, you can replace it with the W letter. And for the height, H. So what the library will be doing is replace W and H with the actual width and height of your screen. So let's first clear the screen and type the command draw line with the width and height parameters. So it's replacing W and H with the actual width and height of your screen. So you can see here the real numbers are outputted to the serial monitor. So you saw me sending two commands sequentially. So first the clear screen command, and after that the draw line command. But you can combine those by using a comma. So for example, I can specify clear screen, and after that the draw line command, and sending both of them at once to the Arduino. So the library will first clear the screen and draw the line. And you can even enter another command at the end of the text by, let's say, another line. And let's say this time the height would be 150. So it's drawing two lines, clearing the screen, draw the first line, and draw the second line. So you can combine them like this by using comma. So this is very powerful. Let's say, for example, I want to draw the first line blue. So what I can do in this series of command is, after clearing the screen, I can change the color to blue. So blue is 001F. And don't forget to put a comma. So clear the screen, color blue, draw the line, that will be blue. And after drawing the first line, I can change the color to draw the second line, let's say red. So red is F800, a comma, and let's send that to the Arduino. So my first line is blue, and the second one is red. There's a command to draw a horizontal line. So the command is LH, and let's say we want to be at position 10, 10, and you have to specify the actual length of the line. So let's say we want a length of 75. So it's drawing a horizontal line, and you also have the command for the vertical line. So the command is LV. So LV, let's say we want it to be at position 150 with a length of 100. So it's drawing a vertical line on the screen. Now we can also draw circles. So let's first clear the screen, and the command to draw a circle is CH. Let's say we want it at position 100, 100, and the radius of the circle 100. So by using the prototyping library, I can just try to, for example, if my circle is not the right size, I can simply go here and change the radius, let's say to 50. So I can adjust my design by just changing the parameters and see if this goes well with what I want. So you can play with the different parameters very, very quickly and try many things. So if I want to draw a circle in the center of the screen, what I can do is, let's clear the screen and use the command ch. So if instead of calculating what is the middle height and the middle width, I can use the shortcut M, which is the middle width, and C, which is the middle height. And let's say I want a radius of 75. So my circle will be positioned at the center of the screen. So again, it's M to replace the middle width and C to replace the middle height. So again, you don't have to memorize all of this. And everything is documented on my GitHub repository. The C and M that you can replace in every parameter of any functions that is supported by the fast prototyping library is documented on the GitHub repository for the library. Now let's draw a filled circle. So the command is CF. Let's drawing it at the center. So M, C, and a radius of 5. So we have a red filled circle. And let's say we want to change the color to blue. So I can go back in my command list and with the arrows keys and with the hashtag change it to the blue color. And I separate the command with a comma, enter. And now my filled circle is blue. I can draw rectangles. So let's say the command to draw a rectangle is RH. Position, let's say 20, 20. With a width of 100 and a height of 25. And I can also draw a filled circle. The command is RF. Let's say position 20 at 50, width of 100 and height of 25. So we are prototyping, and it's the whole idea of the library. I can go back to my command and change the color of the filled rectangle and change it, for example, to, let's say, color red, F800. And I separate the command with a comma, resend it, and this time my rectangle is red. Now we can also draw a rounded corner rectangle. So let's draw one that it will be orange. So the color will be FBE0. And the command to draw a rounded rectangle is RI. Let's say we want it at 100 with a width of 25 and a height of 100, and you have to specify the radius of the corner. So let's say 5. And we can also draw a filled rounded rectangle. So this time the command is RJ. So I can go back in my command list and replace the RI with RJ. And let's say this time I want it yellow. So FFE0. And finally, with the Adafruit GFX library, I can also draw triangles. This is the two last functions, an outline of a triangle and a filled triangle. So to do an outline of a triangle, the command is GH, and you have to specify the three position of the vertices of the triangle. So 10, 10, 100, 100, and let's say 110 and 10. So this is the three vertices. So it's drawing a yellow rectangle. And I can draw a filled triangle, and the command is GF, so I can go back in my command list with the arrow keys, replace the H with an F to draw a filled triangle. Now, before jumping to the demonstration of the commands for the TFT ESPI library, we have to look at the example. So we just saw the example for the Adafruit GFX. Now let's open again the examples menu, go to the Fast Display Prototyping, and this time we're going to choose the TFT ESPI example. Now the driver management for the TFT ESPI library is a little bit easier than with the Adafruit GFX. Basically, you don't have to modify this example, but you have to modify the user setup select header file where the driver for your display must be configured. Here is how to do it. First, you have to go to your Documents folder on your PC, and you will see the Arduino folder. Open it, and in the Arduino folder, you will have the Libraries folder. Open this one, and locate the TFT ESPI folder. Open it. Now you're going to see at the bottom of the folder the user setup select. You have to open this file. You cannot edit it in the Arduino IDE, so you have to edit it outside the Arduino IDE. You can use, for example, Notepad. So I'm going to open it in Notepad. So here is my user setup select header file. And in that header file, you have a lot of display drivers that are compatible with the TFT SPI library. So you have to locate your particular driver and uncomment the line of your driver to activate it. In my case, I'm using a driver called the ST7735 for my little display. So I have uncommented this line, and that's all there is to it. Okay, we're back at the example, and we didn't have to touch it, but we've set up our display driver in the user setup select header file. So in this demonstration, I focus only on the commands unique to the TFT SPI library, and I'm going to use the small 1.4-inch TFT LCD display with an ESP microcontroller. All right, the TFT ESPI example is uploaded to my ESP32 microcontroller, and the library is ready to be used. You see on the right my small 1.4-inch TFT LCD display. And we're going to look at graphics command exclusive to the TFT ESPI library, which offers more advanced features compared to the Adafruit GFX library. But keep in mind that all the serial commands demonstrated in the previous chapter are also applicable to the TFT SPI library. So draw circle, fill rectangle, draw line, they are all applicable and you can use them. Let's open the serial monitor and make sure the no line ending is selected. And the first command is a command to draw a smooth circle. So the command is CI, and we're going to draw the circle in the center of the screen using the shortcut NMC. The radius will be 50. Let's draw it with a blue color, 8E7D, on a black background. So it's drawing a blue circle, and the blue circle is smooth because the TFT SPI library is using an anti-aliased feature, which is a kind of technique to reduce the appearance of jagged edges. So this is why we need to specify both the foreground color and the background color to allow the TFT SPI library to do an anti-aliasing technique on the object. The next command is similar. We're going to draw a circle, a smooth circle, but this time it will be filled. So the command is CJ. Again, we're going to put it at the center, MC, a radius, let's say 65, and let's clear the screen before drawing the circle. And we're going to draw it green. So color green is 07E0, again on a black background for the anti-aliasing feature. So it's drawing a big green circle, and it's a little too big. So let's reduce the radius to, let's say, 55. The next command is to draw an ellipse. So the command is CE. Let's first specify a color. So hashtag, and let's say we're going, let's say a white color, which is FFFF, and semicolon. And to draw an ellipse, the command is CE. Let's draw it at 75, 75, and first radius of 25 and second radius of 50. And let's clear the screen before. So it's drawing a white ellipse. And this time there is no smooth ellipse feature in the TFT ESPI library. So you saw that there's two radius to specify for the draw ellipse. There's a horizontal radius and a vertical radius. So you can play with the parameters of the radius to see the difference on the screen. Now you can probably guess the other command, which is fill ellipse. So fill ellipse is the command CG. So let's have a purple filled ellipse. So let's be for DA90, hashtag DA90 for the color purple. So CG. And again, we have to specify the center. Let's say 75, 75, and both radius. And we have a filled purple ellipse. Now we can also draw arc with the TFT SPI library. So the command to draw an arc is CA. So the first parameter is the position. So let's say 50, 50. The next one is the radius, the outer radius and inner radius of the arc. So let's say it will be 50, 40. And the start and end angle of the arc. So let's say we start at 0 degree and end at 180 degrees. And we have to provide a foreground color. So let's say 9003 and a background color. So it will be black, because the last parameter is for specifying if we want a smooth arc. So to have a smooth arc, we pass the value of 1 as the last parameter. So let's clear the screen before by adding the X command. So we have a red arc. Not showing well on the screen. Let's change the color to, let's say, let's put it green. So 07E0. And you can play with the start and ending degrees. For example, let's say 66 and ending at 213. Now let's look at the difference when we change the last parameter to 0. So 0 means not a smooth arc, so a jagged arc. And you can see that we see the jagged edges on the arc when it's not smooth. Now there is actually a specific function in the TFT SPI library to draw a smooth arc. So it's almost the same. It's the same parameters, except that the command is this time CB. And the last parameters is not for specifying if we want a smooth arc, because the function is to draw a smooth arc. It's to specify if we want to have a round end. So we're going to see what it does. But first, let's show the function. And let's see the difference between the draw smooth arc function and the draw arc with the parameter smooth. Change it here at the end. So the draw smooth arc is a little bit smoother. So let's move this one to 100, 100. And let's not clear the screen so that we see both of them. So we can see barely the difference between both of them. They're both smooth. So basically there's no difference. But if we put a 1 at the end of the draw smooth arc function, it's going to draw round ends to the arc. So let's move it a little bit inner so that we see it better. 75, 75. So now we see the round edges a little bit better. So the parameters regarding the inner and outer radius, you can actually, these two parameters, 50 and 40, you can actually, so the difference between the two is actually the thickness of the arc. So if I specify here 45, it's going to draw an arc a little bit thinner. So let's say I move it a little bit inward. It's a 65, 65 so that we can see it. You see that the arc is thinner. Now we can draw smooth round rectangle with the library. So the command is rs. So let's first clear the screen. rs. Let's say position 25, 25. The radius of the corners, let's say 5, 8. And we need to specify the width and the height. So 50, 60. A foreground color, because it's a smooth rectangle. So the foreground color, let's see, 820 with a background of 0. It's drawing a red smooth rectangle. So again, it's anti-aliased. So almost no jagged edges. And you can guess the next function, which is the last for the TFT ASPI library, which is fill smooth round rectangle. And the command is RT. So let's clear the screen first. RT, the position of the rectangle, the width, the length, the radius of the rounded corner, the color, the foreground color, and the background color. And it's drawing a rounded rect, smooth with no jagged edges. So this was the last command for the TFT SPI library. And next, I'm going to show you tips and tricks with the library. And if you like the video so far, please hit the like button and subscribe to the channel. So next, the tips and tricks. Here is a nice tip. Let's put some shape on the display. So this set of commands is going to draw a square with a little shadow. And this other set of commands is going to draw a green circle with a shadow. So let's pretend that we're satisfied with what we see on the screen. So what I can do is copy the code outputted to the serial monitor by the library, copy it, and paste it into my sketch, and upload this to the Arduino. So it will become the base drawing for our prototyping. So it's uploading. So the screen is refreshing with the square and the circle. So let's try to print square under the square. So I'm going to first change the color to black, change the text to be a little bigger to 2. I'm going to set the cursor to column 5 and line 100 and print the square text. Now you see it's a little bit too low for my taste, so I'm going to raise it a little bit. So let's say 90. And the column, let's say 9. And you see that your drawings are kind of overlapping. So what you can do is reset the Arduino to your base drawing, and from there make your adjustments so that you don't have any overlapping objects because you're prototyping. So that's a nice tip that I use often. Now you see here that the code that is outputted by the library to the serial monitor, all the code is preceded by the name of the display, the variable name of the display, which is TFT in that case. That's because we initialize the FastDisplayPrototyping library with TFT, which is the name of the variable for the display that we use to name the actual display when we initialize it. So if this is different in your code, you can just, for example, let's say your display variable is called display. You can change it here, re-upload the code to the Arduino. And now when you're using the serial monitor with commands, so let's go back, it's going to use the display variable when showing commands. So you can cut and paste them and they're going to work. Now, if we look at the documentation of the FastDisplayPrototyping library and look at the serial commands reference section, you see a green badge and a blue badge for each command showing which one is compatible with the Adafruit GFX or TFT SPI. For example, the draw smooth circle is only compatible with the TFT SPI library. That's why there's only a blue badge. And you see the function, the actual function, the equivalent serial commands, and the description of the function on the right. So there's other information in the documentation that you can look at. And I'm just scratching the surface with this library. So I'm going to make regular updates to the library, and I release videos highlighting the newest features as they roll out. So be sure to subscribe to the channel to stay informed and up to date. Thanks for watching.